Welcome back. We've heard your journey into industrial automation, explored how modern factories work, uncovered lessons that textbooks often miss, and listened to some incredible stories from the factory floor. Now, I'd like to make this profession feel real for our listeners. Instead of asking the usual question, what does a typical day look like? I'd like you to walk us through yesterday. Hour by hour, what did your day actually involve?
That's a great question because no 2 days are exactly the same, especially when you're running an industrial automation startup. Yesterday started around 7 a.m. The first thing I did wasn't check emails, it was review overnight alerts from a few client sites. Some of our industrial IoT solutions monitor equipment continuously, so we receive notifications if certain machine parameters cross predefined limits. Fortunately, there were no critical issues, but one production line had reported an increase in motor vibration. It wasn't serious enough to stop production, but it was worth investigating before it became a larger problem. That's one of the advantages of connected industrial systems. Instead of waiting for a machine to fail, you can often identify early warning signs.
So, your day begins even before you reach the office.
Exactly. Around 9 a.m., we had our engineering stand up meeting. Our hardware engineers discussed the status of a new embedded controller prototype. The firmware team shared progress on implementing a communication protocol. Our software developers demonstrated updates to the monitoring dashboard. Meanwhile, the field engineers prepared for customer visits. Although everyone specializes in different areas, every team depends on the others. Hardware, firmware, networking, industrial software, and mechanical systems all need to work together.
That really highlights how multidisciplinary this field is.
Absolutely. One person rarely builds an entire automation system. It's a team effort. An electrical engineer may design the control panel, an embedded engineer develops the controller firmware, an automation engineer configures the PLC, a software engineer creates dashboards and reporting tools. A networking specialist ensures reliable communication between devices. A mechanical engineer integrates everything into the machine. Each role is important and success depends on collaboration.
What happened next?
Around midday, I visited a customer's manufacturing facility. One of the most valuable things about visiting factories is that you see how equipment is actually being used. Sometimes a design looks perfect in the office, but operators interact with it differently on the production floor. That feedback is incredibly valuable. Yesterday, we noticed that maintenance technicians had to walk across the plant every time they needed machine diagnostics. So instead of adding more hardware, we redesigned the interface to display diagnostic information on portable industrial tablets. A small software improvement ended up saving the maintenance team significant time every day.
That reinforces something you've mentioned throughout this conversation. Good engineering starts with understanding people.
Exactly. Technology should simplify work, not complicate it. One of the biggest mistakes engineers can make is designing systems around assumptions instead of observing how people actually work. The best solutions are often the simplest ones.
What does the afternoon usually involve?
The second half of the day is often dedicated to product development. Yesterday, our team reviewed a prototype for an edge gateway that collects information from multiple industrial machines and securely transfers selected data to cloud based analytics platforms. We discussed questions like how much processing should happen locally, what happens if internet connectivity is temporarily unavailable, how do we ensure cybersecurity, how do we keep response times fast while still collecting useful production data. These aren't just technical discussions. They're business decisions because reliability directly affects customer operations.
You've mentioned edge computing several times today. Why is it becoming so important?
Because factories can't afford delays. Imagine a robotic arm that needs to avoid a collision. It can't wait for instructions from a cloud server located hundreds of kilometers away. The decision has to happen immediately. Edge computing allows important decisions to be made close to the machine while still sharing useful information with centralized systems. It's one of the technologies helping manufacturers build smarter and more resilient factories.
Let's shift our focus to the future. We constantly hear phrases like Industry 4.0, smart manufacturing, AI powered factories, digital twins, autonomous production, and predictive maintenance. How much of this is already happening?
More than many people realize, many factories today already use machine vision for quality inspection. Industrial robots collaborate safely with human workers. Predictive maintenance systems analyze vibration, temperature, and energy consumption to identify potential failures before they occur. Production managers monitor live dashboards from anywhere in the world. Artificial intelligence helps identify production patterns that would be difficult for humans to detect manually. This isn't science fiction, it's already becoming part of modern manufacturing.
Does that mean AI will eventually replace automation engineers?
I don't believe so. AI is an incredibly powerful tool, but it still depends on reliable data. Someone has to design sensor networks. Someone has to build embedded systems. Someone has to configure industrial communication. Someone has to integrate machines with enterprise software. Someone has to validate that AI recommendations are safe and practical. AI will make engineers more productive. It won't eliminate the need for engineers who understand industrial systems.
What kinds of careers do you see emerging over the next 5 to 10 years?
We're already seeing demand grow in areas such as embedded systems engineering, industrial IoT development, automation system integration, robotics engineering, edge computing solutions, smart manufacturing consulting, machine vision engineering, industrial cybersecurity, predictive maintenance engineering, digital manufacturing solutions, industrial data analytics. What's exciting is that many of these careers didn't exist or were much smaller just a decade ago. As manufacturing continues to evolve, new opportunities will continue to emerge.
Many listeners are probably wondering where startups fit into all of this. Large companies dominate manufacturing, so is there still room for entrepreneurs?
Absolutely. In fact, I think this is one of the best times to build an industrial automation startup. Large manufacturers constantly look for innovative solutions that improve efficiency, reduce energy consumption, enhance safety, and simplify operations. You don't need to build an entire factory. You can solve one specific problem really well. Maybe it's an affordable predictive maintenance solution. Maybe it's a low-cost industrial monitoring device. Maybe it's a machine vision application. Maybe it's a specialized industrial IoT platform. Every successful startup begins by solving a meaningful problem. That's exactly how our own journey started.
If someone listening today dreams of launching their own automation company one day, what's the first step?
Spend time understanding industry problems before thinking about products. Visit factories, talk to operators, observe maintenance teams, ask production managers what frustrates them most. The best business ideas don't usually come from brainstorming sessions. They come from paying close attention to real-world challenges. Engineering and entrepreneurship both begin with curiosity.
That's an inspiring thought. Today's conversation has shown us that industrial automation is far more than programming machines. It's about solving meaningful problems through collaboration, engineering, data, and continuous innovation. In the final part of this series, we'll ask one last question. If you could go back in time and speak to yourself as a third-year engineering student, what advice would you give? We'll also discuss the skills worth investing in, technologies to prioritize, common mistakes to avoid, and one final message for everyone beginning their journey into industrial automation and embedded systems. Don't go anywhere. We'll be right back.